Hello. Thought I'd share a little bit more with you about the upcoming rewrite for the CS1 Game Engine. What you're looking at right here is another stress test that I'm running. This stress test is with 1,000 of these models that you can see here that are loaded as GLTF models. And then it's just using a custom shader material. It's varying the color, obviously, for each of the instances there. Altogether, there is 1,517,000 faces just with those instances of that GLTF model. So more than 1.5 million faces. And I can tell, the impact. It's definitely apparent, but it's still playable, even on the Oculus Quest. I just went and tested it on the Oculus Quest, and it's all right. It's not definitely not beckoning for more and more things to be added. It's getting near kind of like the limit. One thing I must say is when I made these models, these little CS1 GLTF models, I did not optimize whatsoever. So if you look here in Blender, I just basically made some text really quick with the font that I liked, and I converted it into a mesh and literally kept oodles of vertices there. And as a result, have a lot heavier weight, a lot more stress on the system than I would otherwise. So I am sure I could reduce the vertice count on these by about 80%. That was my estimate. So I could get comparable geometry there easily with 80% less faces. Again, this was done as a stress test. Over 1.517 million faces. Really interesting. As you can see, I also am using my A-frame outline component, not only on the torus over there, but on the head and body of this simple avatar, using a yellow outline on the avatar and that obviously a green outline that's on that torus. So pretty happy with the performance here with over 1.5 million faces. Okay, that's pretty good. Let's take a look at the code. This is just all dumped into a very easy to access HTML file where I load in the game engine in its current state, load in the game engine, and then I call this a hybrid, a no-build hybrid, because I'm not building any of the JavaScript for the actual game. I mean, the engine is not even minimized either. So that engine's not minimized, and we're not minimizing or bundling up, obviously, this code down here. So that's what I mean by no build. And it's a hybrid, meaning that I'm showing how you can even use HTML with a declarative approach and add things up here, and then you can add your own game logic in the script down here at the end of the body. Notice that this is encapsulated in a CS1 on ready right here. So basically, if you're not aware, the underlying A-frame will have pretty much a scene loaded event that takes place, and when that scene loads, I will also be able to hydrate certain game engine specific things that are waiting on that A-frame hydration, or if you want to say component initialization, component and system, entity, component, and system initialization, because it's an entity component system. Once all that initialization is completed, or the A-frame hydration is completed, however you want to say it, then I can go ahead and perform a CS1 hydration with anything additional. And then after that, I will take care of this callback that's passed into the CS1 already. So that's kind of like the cascade of events. And if you look right here, a little bit of my API semantics that I'm using, CS1 add, and you can add something. So if you're going to add something, you put in the name of a primitive, and you can also pass in an object that contains the properties and values of the way that you want to customize that primitive. And if you do have something, you can add things also that are not even included. Like this primitive is included in the engine so far, but you could add other primitives that aren't included directly, as long as they're mentioned in this lib map that I'm putting together, and it will dynamically load them, and it will resolve a promise. And you can even put a third argument in this add call, and you can even pass in a URL and just say, I want this primitive, and this is how I want to customize it, and then comma, and it's defined in this file at this particular URL, and it will all happen asynchronously. Like I said, there is also a lib map, like a library mapping. So if I go over here into the source code, into the engine, you can see over here I have a lib map, and I just have a couple examples in here right now. I'm going to have a lot more libraries already prepared that you can just access just by referencing them, so you don't have to look up the URLs for where they're at. And this enables to keep the core game engine bundle really minimal, and enables the user of the engine to be able to just say, hey, I want a jukebox, or I want a trail. Oh, actually, I should take the trails out, because I'm actually putting the trails in. I should actually take this out, because I'm putting the trails are going into the engine. They're going to be a built-in. Yeah. So right now, I guess I just have the jukebox in two different forms. CS1 jukebox. It's basically the same. There's two primitives basically defined here. A jukebox and CS1 jukebox, both defined in the same file. So that's what the lib map is. You can even take a peek at it as a developer. It's going to be in the utils, so you can even take a look at it in the utilities if you wanted to. So it's actually brought into the CS1 utils. There's only two things in it so far: load script and the lib map. So the lib map gets brought into the utils. And what else can we point out here? Well, under this current example, I guess I can illustrate how long it takes to load up those 1,000, well, actually put it this way, over 1.5 million faces. And it's also doing some asynchronous script loading as well. So let's see how it does that. with the asynchronous script loading and over 1.5 million faces. Not too shabby, right? Over 1.5 million faces, and it was asynchronously pulling in a script. Which script in particular was it? Actually, it was pulling in, is that the one I was just doing? No, I'm actually in the staging area over here. It was pulling in the outline, yeah. So over here, the outline component that was getting brought in asynchronously. You can see right down here, I call that player avatar body, set the outline component on it with the color of yellow, pass in the URL for it, and then I apply it to the same outline to the head. I don't have to pass in the URL any longer because obviously it would have resolved and would be available at that point. And then I also use the outline on a completely different object, which was the torus, which was defined up here, just to show you I'm accessing something that was defined up here in the scene. So loading all of that, or loading that asynchronous file, doing the rendering of over 1.5 million faces. And let's see that again. How long does that take? That's not bad for over 1.5 million faces and asynchronously getting that outline code. And it's not like it's getting it from the greatest CDN in the world either. I'm actually using GitHack. Right now I'll probably use another CDN eventually. But yeah, not too shabby. I am pretty happy. Definitely shows a little bit of an effect. Things could be a little bit smoother, if I had optimized it a little bit. But again, this is a stress test, and I can easily get that same visual fidelity that we see right there on those CS1 meshes. We can get that same visual fidelity with about 1/5, maybe, or even less vertices. I would argue we can even go down to 1/10 of the number of vertices and faces as well, by about 1/10. So again, just a stress test. Pretty happy with everything so far. Seems that go through some of the other semantics right there. If you look, I do set, so I can set a component. So over here we can add an instance. If we didn't want to add it immediately, there's also a create method that we can access directly. We can say CS1 create if we wanted to kind of just cache a whole bunch of collectibles or something and just hold on to them and spawn them later or something. But if you want to just add primitives, you can just mention the primitive, add the primitive. Over here, I'm just showing you the classic. Here's like the classic way of doing it. Set the attribute to add it. So the set attribute still works. You can still use the classic add a component by setting attribute. And this is, when you're doing the set attribute, this is not asynchronous. And there will be times where you would want to do that, right? Potentially. Rather than having to do this, because whenever you're doing set on outline, it's it's asynchronous. It's going to return a promise. And down here we have the then, and in terms of the consequence of after loading that outline component, I use it 2 more times. I use it on the head, I use it on the torus, and then I also have this game add environment. I'm just going to probably get rid of that and scrap that, and I don't know why. Yeah, so I haven't gotten rid of that yet. I'm gonna probably just go because the environment is just a standard component anyway, right? So I probably will just be getting rid of that method, unless there's something really special about that. But probably just because over here I just go cs1.add, and I wouldn't do add environment, because the environment is usually just a component that's added on the main scene. I would probably just go cs1.scene.set environment. I mean, I can already do that rather than add environment. So there's a lot of things. I'm just playing with different semantics, different ways of expressing the API, kind of playing with it different ways in terms of, what if somebody wants to add some code just really quickly in HTML because they found it somewhere, so they just want to dump it in. It's just some A-frame kind of HTML code, so they can just dump it in there if they want to while they're prototyping. They can go down here and they can access all of the CS1 special API sugar. They don't even necessarily need to put this code in the onReady callback, but they do if they are going to be counting on the any properties that are going to be hydrated, in the cascade of A-frame hydration and CS1 Game Engine hydration. But there's a lot of instances where you might not even be doing that. You might just simply be avoiding, but not necessary certain times to even have this CS1 onReady in your code. So I'm just, like I said, I'm just exploring a lot of opportunities here, and I'm excited with the performance. That's the thing. I'm taking things slowly, exposing things really slowly. Probably next up, I'm just going to be getting into the devices again, handling the devices. I'm already printing out when it loads up. I'm already basically just printing out all the device information that A-frame gives us already anyway. See, A-frame gives us all this information. Whether it's Oculus, whether you're on the Oculus, So this is really nice that A-frame provides all this. So I'll do all the kind of branching logic based upon all this information. If it's on mobile, then we'll start to add some mobile controls. If it's mobile but not Oculus browser, because Oculus browser will also show up as being mobile true. So you need to, kind of just make sure it's Oculus browser is true for the Oculus specific stuff. So basically I'm going to be doing the device specific controls next, and that's what I intend on. That's what I plan on doing as of today. That's what I plan on doing next. Taking things nice and slow. If you like to get involved in this process, I really want to make this an efficient rewrite so that people can, really make some, commercial grade applications when they're done with it, where it has that really nice polish and great performance, and you can get things done in a quick fashion. So that's it. Just wanted to share that much with you. Hope you're all doing well. Feel free to reach out, and I will talk to you later. Take care.